So today we're going to be talking about the rectangular approximation method. Okay, so there are three methods we use with rectangles. We have LRAM, RRAM, and MRAM. LRAM being left side, right side, and midpoint. Okay, so depending on which one we use, depends on which side our rectangles will hit our curve at. So for this problem, we're going to be using RRAM. Okay, and we're going to use it to estimate the area under the curve from -1 to 3 using 8 intervals for the function. Okay, so we're going to be splitting from -1 to 3 up into 8 intervals, or 8 rectangles. Okay, so let's draw a picture real quick just to give an idea of what this looks like. So our function is -1/2 x squared plus 7. So this is a parabola that's been vertically compressed, reflected so that it opens down, and then shifted up 7. So a vertex, and I'm going to use every 2 to be 1. So it's 1, 2, 3, 4, 5, 6, 7. So this is where my vertex is. Okay? And then I'm going to use, this is -1, 1, 2, 3, 4. Our x-intercept is going to be somewhere around here. So with the vertex up here, it's going to look something like this. Okay, so there's what our parabola looks like. Okay, so we're going to be creating 8 rectangles. Okay, so basically when I draw these rectangles in, they're going to hit at the right side. So from -1, so there's 1, 2, 3, 4, 5, 6, 7, 8. My first rectangle is going to be right here, come up, hit on the right side. It's going to look like that. Then my second rectangle is going to look like this, where it hits right there. And then the third one looks like this. So you see what I'm doing? Basically, since every 1/2 we're going to have a rectangle, and the rectangle itself hits on the right side of the top of this. Okay? So I'm using my curve to actually create the boundary for my rectangle. Okay? And then my last one here. So these are my rectangles. 1, 2, 3, 4, 5, 6, 7, 8. 8 rectangles. Now, notice on the left side of the vertex, we have some overage here. But on the right side, we have some missing area. Okay, so whatever number we come up with, this is probably going to be less than, the approximation is going to be less than the actual area. But we'll get a pretty good idea. Okay, so let's look. I've created a table here. So my first height that I need to find is going to be at -1/2. So the height of my rectangles are coming from the right side because I'm using RRAM. If say I was using LRAM, then I would start at -1. But my first number I'm going to find is -1/2. So I'm going to plug -1 into my function. Sorry, -1/2. So f of -1/2 equals -1/2 times -1/2 squared plus 7. And if you have a calculator, then that would be the easiest thing to do, is just plug them into the calculator. Or if you have a graphing calculator, you could plug the function in and then go to the table and just make sure this table is set up at 1/2 increments. So 6.875. Okay, so when I plug -1/2 into the function, it gives me 6.875. Obviously, my next one is 0. because this is right here. The right side, the height of this one, is when f equals 0, and that's going to be 7. And then I'm going to plug in positive 1/2, and obviously since it has symmetry, it's going to be the same as negative 1/2. Then we're going to plug in 1 and get 6.5, and then we're going to plug in 1.5 or 1.5 and get 5.875, and then we're going to plug in 2 and get 5, and then 2.5 and get 3.875, and then plug in 3 and get 2.5. Okay? Now, all of these numbers right here, these are nothing more than the heights of each rectangles. Okay? These are not areas. These are just the heights, and the heights come from the function itself. Okay? So basically what we have to do now is we have to add up all of those heights. Okay? So when you add up all of the heights, you get your total height, which is 44.5. And again, this is just the heights. But now what I'm looking for is my area, which is going to be my total height times the width of each rectangle. Okay? So in this case, since all of my rectangles have the same width, I can do this. So it's 44.5 times the width, which is 0.5, which gives me a total area, or approximate area, of 22.25. Okay? So that is an approximation of the area under this curve. Okay? And that's what we're looking for. Now, the actual area, if we actually did like perfectly, is 23.3 repeating. That is the actual area. Okay? This is just an approximation. And we said it was going to be under because it looked like we were missing more of the area than we had overages. Okay? So in this case, it is pretty close. I mean, within 1 point, that's pretty good. Okay? But that's basically how you do it. Okay? You kind of draw a picture, you set up your rectangles, you figure out which one you're using, then you use that height at that side. So if this side height comes from the right side, if it were LRAM, we would have started at -1 and only made it to 2.5. And of course, if it were MRAM on this one, which would have been a little more difficult, we would have had to find the height. Instead of finding it at -1/2, we would have found it at -0.75. Which just means that our decimals will be a little bit uglier, but still just the same process. All three have the same process.